Welcome all. This is Kiran Patil, Assistant Professor in Computer Science and Engineering Department, BLDACET, Vijaypura. Now, friends, today we shall look into the basic two-dimensional geometric transformations. Now, you can see on your screen, I have represented a two-dimensional translation. First of all, before we go into the details of translation, let me just briefly introduce three different transformations that exist in two-dimensional geometric transformations. So the first one is translation, the second one is rotation, and the third one is called as scaling. Now we come to the two-dimensional translation. What is translation? In simple words, translation is nothing but the movement of point from one position to the other position. To explain more, consider a point P with the values of x and y moved to a new position P dash with the values x dash and y dash. Right? As shown in the figure, you can see that there is a point P which is being moved to the new position P dash, and that is with the help of a translation factor T. Alright, that means when you apply this translation on the original point, it gets transferred into the new point P dash. Now, to translate a two-dimensional position, we add translation distances, that is tx and ty, to the original coordinates x comma y to obtain the coordinate position x dash comma y dash as shown in the figure 1. That is the figure that you have seen in the earlier slide. So basically, x dash is nothing but x plus tx, y dash is nothing but y plus ty. That means we are adding these translation factors tx and ty to the original values of x and y in order to get the new values of x and y, which are termed as x dash and y dash. The translation distance pair tx comma ty is called the translation vector or the shift vector. We can express equation 1 as a single matrix equation by following column vectors to represent coordinate position and translation vectors. For example, if P is a column vector or column matrix, what we call it as x and y, P dash is x dash and y dash, and T is tx and ty. This allows us to write the two-dimensional translation equation in the matrix form, that is P dash is equal to P plus T, where P dash is the column matrix of x dash and y dash, P is the column matrix of x and y, T is the column matrix for tx and ty. Now, take an example here. Moving a polygon position A to the position B with the translation vector minus 5.50, 3.75. That means the first figure A represents the original position of the polygon. The next one represents the changed position of the translated position of the same polygon. Now, how is this achieved? This is achieved simply by adding the translating factors. That is, tx is equal to minus 5.50, ty is equal to 3.75 to all the points of the polygon. All the points of the polygon that is shown in figure A. Alright. So we can take this as an example here. For a polygon with the vertices 5, 5 and 15, 5, 10, 8, translate the polygon with the translate vector minus 5, 3. Students, I want you to try this at your home and get me back with the result. It's very simple. Every point of a polygon is given. Every point's x and y values are given. You also have a translating factors, which is minus 5 comma minus 5 comma 3. That is tx is equal to minus 5, ty is equal to 3. All you got to do is simply add these translating factors to the points that are defined. And obviously you will be getting the translating points, or the translated points. Alright. Now this is the code that we use in OpenGL in order to translate polygon the polygon, or any geometric shape, right? So basically what we do is we define a class WCPT2D, that is the word coordinate for the point in a two-dimensional. Okay, so it's being short formed as WCPT2D, and here we have two data members that are declared in public, that is GL float x comma y. Then we write the translate polygon function. Basically it translates the points of the polygon. What we do here, we take the vertex, that is WCPT2D star words, that means the vertices that define the polygon. Also we define the number of vertices that the polygon is comprised of. Then we have the translating factors tx and ty. Okay, so basically we define a variable gl in k, so that we could use that variable in the for loop, in the further processing. So for k is equal to 0, k less than n words, that is number of vertices, k plus plus. Words k dot x is equal to words k dot x plus tx. So basically what we are doing is we are visiting every vertices of the polygon, and we are adding tx and ty to the values of x and y of that vertex in order to get the translated vertices. So once we finish up with this for loop, we basically define a new polygon with the new vertices, and the code for that would be GL bin GL underscore polygon for k is equal to 0, k less than n words, k plus plus, GL vertex 2f vertex k dot x. Now these are the translated vertices. Values of x and y are the translated values. They are x dash and y dash. So with the help of that, we define our new polygon, or our translated polygon. Right friends, I hope that you have enjoyed this video. You have acquired the knowledge of translation from this video. If you like this video, please hit the like button. Thank you very much. May God bless you.